Well, we've reached the end of another skill, explaining network communication with the OSI model. Let's do some review. Do yourself a huge favor as we go through these questions and pause when I do after reading each question so you can think about what the answer would be. Then I'll come back and say the right answer as well as explain why it is right and some of the others are wrong. Here we go. Question number 1. The OSI protocol is the preferred protocol stack in most networks today. True or false? The answer is actually false. Burnt. TCP/IP is the preferred protocol stack. The OSI protocol is barely used at all today, although there are some corners that use it primarily for a routing protocol known as ISIS, but that's a whole other topic. The OSI reference model is the preferred reference model that we use to describe network communication. Question number 2. Which layer in the OSI model houses the network-aware application? The answer is actually A, the application layer. That's where the application itself lives at layer 7. It then chooses to communicate, passes its data down to the presentation layer, that's layer 6, where it uses a standard language that both sides understand, like JPEG, HTML, whatever communication method it's using. It then drops it down to layer number 5, the session layer, which starts or ends the session with the other side if it's not done already. Chooses TCP or UDP down at the transport layer, not pictured here, layer number 4. Gives it a logical IP address at the network layer and a physical address at the data link layer, that's layer number 2, and then finally communicates it across the network at layer 1. Question number 3. TCP or UDP blank allow an application to know which data is meant for a specific service. The answer there is ports. There are actually 65,536 unique ports for each protocol, TCP and UDP. Ports 1 through 1024 are considered well-known ports where you have to actually register with the government bodies that be if you actually want to use one of those, or you should anyway. Not all application manufacturers do that. And these things allow our computers, when they're communicating, to differentiate what service they're trying to communicate with. The data comes into an IP address, but the server needs to understand what application you're trying to speak with on that server. That's the job of the port number. Question number 4. The network layer allows for no control of the logical addressing when sending or receiving data. True or false? The answer is actually false. Unlike the data link layer, where the physical addressing is typically burned into a network card, that's the MAC address, we, as a network administrator, have full control over how our networks are addressed up at the network layer. We get to choose the IP addressing scheme. We get to choose what subnetting method we use. We are fully in control. Question number 5. Imagine that you are sending data to a server on a different network with an IP address of 10.1.1.55, with a MAC address of, and you can read that right there, and the IP address of your nearest router is 10.0.0.1 with a MAC address of that guy. In this instance, what would the destination MAC address be on the data packet when sending from the original data source? Well, if you're like me, you have to draw this one out. We've got the computer over here on a network that's communicating to a server somewhere else. We know that there's a router right here because we know this is on a different network. What happens between here and here? We don't know. It's just saying that there's a remote server with an IP address of 10.1.1.55 and a MAC address of blah, blah, blah. We'll just put EE:FF as the MAC address. The IP address of the nearest router is right here, and that is 10.0.0.1 with a MAC address of, I'll just put BBAA right here. Again, what goes on between here and there doesn't really matter because the question is asking what would be the destination MAC address in the data packet when sending from the original data source. That's us at our happy computer. The answer is this guy, C. We have to use our router to get to that server. The destination IP address would be here. That's why we need 2 layers of addressing. We have to get to here in order to get to here. And that leads us to question number 6. Blank is added to the end of a frame that runs a hash to ensure the data being sent is the same as what's received. Fill in the blank. The answer here could be many things. You could put CRC, which stands for cyclical redundancy checked, or if you're a spelling whiz, you can spell cyclical, I can't even say it, much less spell it, cyclical redundancy check in that blank. Or another name for that is FCS, frame check sequence. A little easier to spell, but if I was giving a fill-in-the-blank question, I would just fill that in. Now, those of you studying for an actual certification exam, fill-in-the-blank has been removed as a question type for quite some time. The reason that I use them here is because it makes you think versus a multiple choice question where sometimes it's just, oh yeah, that's what that one is. And that leads us to the end of the review of explaining network communication through the eyes of the OSI model. I hope that was super helpful for you to either expose some weaknesses or make you feel pretty confident that you got that information. When you're ready, move on ahead. I hope this has been informative for you, and I'd like to thank you for viewing.